This is GCSE Physics, Unit 2, Ohm's Law and Resistance. And this is a revision podcast which you can watch before you try your past papers. Okay. Now, the first thing you may have to do is you may have to set up a circuit to measure how current changes as voltage across a wire or resistor changes. And this, once you learn this kind of setup, this can be applied to quite a lot of other experiments that you also have to do. So if you want to change your voltage, you have to have some source of power here, and I've just drawn a battery symbol, and you need something to change it. Now the thing that you need to change it is going to be a variable resistor, which I'm going to draw in here. And whenever you draw a variable resistor, you have to put an arrow through it. You would also get away with, instead of putting a variable resistor in there at all, you could just put an arrow across your power supply, meaning that it's a variable power supply. And whenever we did this in class, we actually used a variable power supply. So what else do we need to do? We need to measure voltage and we need to measure current. So this box here is representing a resistor or a wire. And given that a resistor very often is made up of a certain amount of wire wound around something, then that makes sense that you could just draw a little box for it as well. And so you need to measure voltage and current. So to measure the current in your circuit, you use an ammeter. Your ammeter has to be placed in series in here, and so this must be your ammeter here. To measure the voltage across a resistor, you have to put a voltmeter in parallel. So this must be your voltmeter here. Now this setup is very, very similar for the other three experiments that you did whenever you looked at voltage and current changing through different components, and the only difference is that you just change this resistor for the component you want to use. You measure voltage across it and the ammeter always goes in series. Right, whenever you carry out that experiment for a resistor and you plot voltage across against current, you get a very good straight line graph like this. So these are the points. If you are asked to do this on a graph, please make sure that you have got nice X's or even dots with a circle around them, but make them quite definite because you will be getting marks for actual points. So if you get a straight line through the graph for a resistor or a wire, you should be able to say something about the relationship between the current and the voltage. So we know that when we get a straight line graph which goes through the origin, we can say that these two things are directly proportional to each other. And so V is directly proportional to I. And the directly proportional symbol is this little fish symbol or alpha sign. What does directly proportional mean? This means that as values of V double values of I double also. So you can see this if you had something like 2 here and you doubled it to 4, you can see that your value there has approximately doubled. And that's what directly proportional means. And that's always shown by a straight line graph which goes through the origin. And that's how you know when you have direct proportion. So if you see a graph like this, this is more than just something increases. I mean, you could have a curve there, and that would be an increase. I's increasing, and V's increasing, but it's not directly proportional because it's not a straight line. So this graph leads us to something called Ohm's Law. And Ohm's Law is about this direct proportion idea. So the voltage across, I'm going to write a wire or resistor, is directly proportional to the current across it, or the current passing through. Now there's a provided part to this. I might just scan in this a little bit so that you can see this a little bit better. So voltage across a wire or resistor is directly proportional to the current passing through it. And the provided bit is that provided the temperature doesn't change or the temperature remains constant. Now that's very important, because if the temperature does increase, that generally means an increase in resistance, and you won't have a direct proportion relationship there then. All right, now we've just said there that Ohm's law, V is directly proportional to I. And to link those two up, we put an equals and a constant in there, and the equals and the constant is called resistance. So we express Ohm's law mathematically using the equation V is equal to IR, or voltage equals current times resistance. And so I'll just scan out a wee bit more there, realising you can't see that properly. So we shorten that off to V is equal to IR, and that's how everybody remembers this law, by this equation, V is equal to IR. So voltage must be measured in volts, current is measured in amps, you can see the amp has just gone down onto the next line there, and resistance is measured in ohms. So how do you calculate resistance from a voltage current graph? Now, it depends on what way the graph is drawn. You have to learn these graphs with voltage across the x-axis. In class, we may have plotted it the other way round. And when you plot it the other way around, the gradient of the graph gives you resistance. When the graph's given to you this way, what you can do is you choose a value of V and go up to your line and then work out what your value of I is from that. And you'd use Ohm's law then to calculate your resistance. So V is equal to I times R. Say, I'm just going to make up numbers here, say that was 10 volts and this was 5 amps. Then V is 10 equal to 5 times R. So if you rearrange that, R is equal to V over I. And in terms of the numbers, 10 divided by 5. So R must be equal to 2 ohms. Now, before I leave this, sometimes your graph may not be a straight line, and there may be a part at the end which starts to curve, say like that, and you might be asked to find the resistance over here somewhere. So what you do is just exactly the same thing. Go up to the line, take your value of V off your line, take a value of I and just divide them. But you know that that part of the graph isn't, this part of the graph doesn't obey Ohm's law because it's not a straight line which passes through the origin, this part here.